Dig a day.
Good day.
Red shirt today, Mr. Cook.
For what cause?
There's a little bit of red on there. Oh, there's the red dress.
Literally.
It's literally the
It's
red dress.
literally
It's just
the
my
red
fault.
dress shirt.
My fault.
And I may have ordered it in blue so that I don't accidentally celebrate Will.
Oh, yeah.
Yeah.
Don't want that.
Or
but now
brown.
you're
Want that.
celebrating Rogers and Allard.
What?
We're celebrating Rogers and Allard.
How?
Orange and blue.
Blue is Privet's color.
Actually, that's a.
Yeah.
That's
And
a,
Allard
that's a-
just belongs to Privet. Because we had blue before Allard did. We lent them a blue.
No,
Yeah.
that's not how that
Yeah.
works.
The only houses with true colors are Privet, Hope.
Rogers. Who's doing my desk?
I did steal your desk. I was gonna come ask you, the classroom was
Okay.
dark, so I was gonna come back. This book, however, are you ready to test it?
Yeah.
Or do you have lots of people that are you sure? Oh, okay. Where was that? Roger's color isn't real.
What?
Mr. Stone doesn't like it.
What?
He keeps trying to make it black, like a pirate flag.
But
Okay, that's like valid though.
See? You don't
But
like
it's
your own
like-
color. Yeah.
Why did they make it orange?
Whittles isn't real because red isn't a real color.
What?
what do you mean? It's a primary color.
No, it's just dark pink.
Oh, yeah.
Fact.
Sure.
Yeah.
No.
Yeah.
No.
Yeah.
Yeah.
It's just dark pink. All red is pink. It's even more concentrated hope. Don't you have hope in your heart? There.
It's a
One.
primary color.
One for me.
It's a primary color.
Yeah.
There's some bias.
Green is just basically stuff you find outside that's like in dirt, so like who cares?
Okay, so then it is a real color.
Yellow's
You're
good.
just like putting it down.
Yeah, way down. But I can't deny it's a real color because we own Ellis.
What?
Well, Mr. Wismer started as a BFA in Privet.
Prove it.
We taught him everything he knows. And Mr. Barrett started as a BFA in Privet. Taught him everything he knows. Oh,
So now you.
Where's Mr. Barrett going next? Yeah, now we own them too.
No!
But we have longer claim on that as well, because Mr. Queen, who you may or may not have heard of,
Yeah.
Yeah.
He
Yeah.
came to, what's it called?
yeah, he house parenting there for 1,000 years.
Okay, what about Mac and Alex?
And Privet has the biggest clock that Mr. Queen has made because Mr. Queen started in Privet and we taught him everything he knows.
Was he house parent in
He was an assistant, we trained him.
Okay, how about Mac and Alex?
Oh, Mac is fine. They're good.
Okay.
They're their own house. We feel sorry for Mac because they have to keep putting up with Ellis.
Yeah.
That's so valid.
I know, everybody's
Everybody
like, yeah.
agrees. Like that's that's
I know. You always insult Ellis, and Mac guys will always take it like one step further. Like it's
I've always noticed that. I've even suggested you should, sabotage this event for us to help. And Mac girls are always like, yeah, actually, you make a fair point.
okay. What about Alex?
And then-
Alex their own house?
What about Hope? We own Hope. No.
Alex literally didn't even have a real color. They adopted purple because they were Barney the dinosaur. I think there's something sus about that.
So you're saying they're not real? Is that
Not real. Oh, it's 8:15. It's time to
So
start.
the real houses
Wait,
are.
doesn't Rogers?
Privet
Doesn't
and
Rogers?
Oh, you were lucky. I'm closing that door.
Mr. Newfield, doesn't Rogers own Hope now? Because wasn't Miss Hedquist in?
What?
Wasn't Miss
still
Hedquist like?
Yeah, Hope took over Rogers. Now Rogers doesn't belong to themselves anymore.
What do you mean?
Privet and
Hope
Mac
took
Yeah,
over Rogers?
and through Hope,
That is what's wrong.
Privet gained.
No, but I thought Miss Hedquist was trained by Mr. Snow.
Pardon?
I thought Miss Hedquist was trained by Mr. Snow.
No, Miss Hedquist was their own house parent.
Right. So the three houses.
There was Hope House. They carved Rogers' house in half.
I I know, and then they had Hope on one side of Rogers.
Have you ever heard the story of Gwyneth House?
No.
Which story?
Gwyneth House
Oh, that's where my mom lives.
is the house before Allard. It's the old Allard house. It was literally the old Rogers house. That is kind of where the Fine Arts building is and the pathway where the Fine Arts is. Run down motel looking building. It was built very badly. It was newer than some other buildings and fell apart because it was built too quick and too cheap. So the Rogers boys are like, this place is too icky. Let's leave here. And it's basically collapsing. The school said, yep, no one can live here. So they built new Rogers house. The boys moved in. And then they said, oh, hey, we have a building. So let's put girls in it. So they thought, what are we going to call it? Well, Rogers House moved, so why don't we, before it moved, they had to deal with the fact that Mr. Rogers, who donated the money for the new Rogers House, had done so in a provision. He left the board when girls entered the school, because that was, unconscionable. And he said no money he ever donated could ever go towards girls. And there must never be a girl in Rogers House. So now they have a problem. This used to be Rogers House. Can they put girls in it, or does it count? But Mr. Rogers has died. So they asked his widow. Widow. Please don't bang the door. I'm in the story. She said, yeah, obviously, you have a new Rogers House. This isn't Rogers House anymore, so of course you would put girls in there. So they said, great, and they put girls in it, and they called it Gwyneth House, which is what Mrs. Rogers' name was. So you literally had Mr. and Mrs. Rogers' house.
Why did they get rid of it? Why did they rename it Allard? Did they just
Because when they built Allard,
they paid for the new one or what?
the Allards were the largest donation by far. When you donate the most amount of money, you get the name building. Yeah.
Okay, but then they cut Rogers in half and put girls in
Yeah, they put Rogers in half. Well, he's dead now, and so once they dealt with
I
that,
hope he's
yeah.
rolling over.
Yeah. We could set up a perpetual motion machine. Just put like a magnet in each one of his hands, and then put like wires around his grave, and then as he rolls over, it would generate electricity.
For the girls' houses.
That would be fantastic. Okay, we have a new thing to do today.
Wait, no, I have a fun Gwyneth House fact.
Yeah.
When it first opened, all of the LGBTQ women moved there because the houses were so toxic for women that all of the lesbians and
They got
bisexuals moved to Gwyneth House and had a
everybody.
supportive house.
Yep.
They were all like, haha, screw you, and they moved into a house where there weren't homophobes.
Kind of the same thing that happened when Hope started. Every time a new house is started.
The gays moved there?
Yeah, because then you can get a house where you're your own.
My aunt
Who's
made it
kicking
for
the door?
It was Luca.
Are you kicking the door? Okay, we've done 28 cows, 30 cows in the fields, 28 chickens.
Hold on, I'll Google something.
Wait,
No, just straight up.
30 white horses
No.
stand on a red hill. First they champ, then they stamp, then they stand still.
That one's so
What?
like everyone knows that one.
Which is it?
I've never heard of it.
Is
I've
it a
never
horse's
heard that
name is
before.
riding?
But no, I just need a chemistry question.
Oh,
Oh, that's
Ka of an indicator whose pH at the midpoint is 5.0.
They need a data table, I think.
Nope, we don't need data too.
They need 10.
What? Ka of an indicator whose pH
Oh, I know
at the
this.
equivalence point is 5. We just did that. Criminal? What? Okay. They kept saying criminal activity. What are you doing? We're going to start today with neutralizations, and then we're going to go in collecting your headings, and you'll have a 4-minute
pH is
quiz. Entirely 4-minute. There's no choice about being 4-minute, but it will be a 4-minute quiz. The first page on your sheet has definitions because we've done mostly all of this because you did it in your lab. So I'll just briefly go over it, and then we'll go to the real stuff. Yeah, that's another question.
the riddle.
What was the indicator we used in our lab?
It was,
Excellent. Spell it.
H-E-N-O-L-E-H. Wait,
Nice try, Felix.
That's close enough, because I don't recall how to spell it, but you got all the letters I'm always worried about.
I got the.
Where'd Felix go?
Sorry, A-E-L-I.
Oh. Hold it, how did Felix get it?
We were there.
He was already in here.
We were already in
He
here.
was always in here. Yeah.
These are lies.
Always been at war with these people.
Mr. Newfeld, what are you talking
There's no
about?
war in Boston.
I think you're listed.
Yes. There will be a formative only quiz right after we do this. We're not going to do this for very long. When you're handing in your evidence. You need this?
No.
Okay.
I'm done, yeah.
Okay. Ahem.
This is so fun, Mr.
Look at laptop away. That's right.
I was in. Oh, I need.
Look at focus.
Can I have the thing?
Come on up. I gave you one.
You did it.
I either did or you said no.
I wasn't. You didn't.
Oh, because there's one in the back there.
Okay. No. No questions. We don't need questions. They'll be answered as we go along. Are they chemistry only questions?
Why do we keep going, like, flying through units?
Because you're here.
So, Felix, if we don't cover all the units on the test, they're gonna keep the units on.
It's a very comprehensive exam. Anything not covered in class will be covered on the final exam.
But you can make it.
It's a thorough course. So, focus, move, think fast. Ability to design and perform neutralization experiments involving the following. We did all of these. I think we'll go over, because the one thing I don't think we did in the lab, we didn't do this. We're going to talk about titration curves starting today. We did primary standards and standardized solutions. There's some definitions below. One of the things you made was a primary standard. And that is requires a substance that's not going to change its mass while you're weighing it. So it can't react with anything in the air. Most common one, of course, to be a problem is oxygen. But you can always have ones that are absorbing water. NaOH will literally sit in a puddle of water if you leave it out in a weighing dish for long enough, and you can actually see drops forming on it. So that's why we didn't start with NaOH. We first had to start with, what was the name of the acid that we used?
That one.
Which one?
Oxalic acid.
Oxalic acid. So we use this one, potassium hydrogen phthalate. These are mostly picked because this is true and they're cheap. Sodium carbonate, if you happen to need a basic primary standard. We were using NaOH, so we need to make an acid to titrate the NaOH. Because we made both of those a standardized solution. A standardized solution is anything that's a primary standard or has been titrated with a primary standard, and you know the exact concentration. Is that here or not? Oh. The pH. No, you just went right by me. The pH at the midpoint, equivalence point, is 5. What is the Ka of the indicator? Has anybody else who's out there got that? The what indicator did we use in the lab? Oh no, this is not from the last day. Spell phenolphthalein?
P-H-E-N-O.
That's about as far as they go. You're good. The most confusing thing about phenolphthalein is the pH in the middle.
Yeah.
Okay. Standardized solution we've done. This is part of your lab write-up, and it was defined in the lab. Titration, a technique for determining the concentration of a solution determined by adding another solution of known concentration. So you've done a calculation for titration. We're going to do a few more as a review. So this unit is mostly review. The main thing we're missing is all the titration curves, and maybe picking the right indicator now that we've done indicators. So the first thing we're going to do is show what a titration curve looks like when you titrate a strong acid and a strong base. Volunteer. Luca, what's your favorite strong acid?
HCl.
Felix, what's your favorite strong base?
OH. POH. base.
Yeah.
NaOH.
NaOH, excellent. Classic. We're gone with the classics. So we're gonna titrate the pH, and we're putting volume of base added. So you can do a titration with volume of acid added. You could do this either way, but the way this is set up, we have our Erlenmeyer with a solution in it. We have our burette. Drop, drop, drop. And maybe it's already turning pink. Way too pink. A little bit of red in there to show you went too far. And volume of base added, so that means this is the base. Question, what is in the flask?
Phenolphthalein.
Yeah.
Oh,
Primary.
It could be phenolphthalein. We don't know for sure yet. Then where do we start the pH?
What other chemicals are pink? Asking.
You started at like 1.
Yeah,
Maximum.
low, below 7.
Yeah.
So we don't know what the concentration is. What the curve would look like
Looks like the curve
is
close to blue.
pH is a logarithmic scale. So at the ends, it doesn't change very much. You get a curve that looks like this as it very slowly changes, and then it goes. Shoo. Oh, that bends a little. That bends almost backwards. Can't do that. Goes. Ooh, I like that. But first of all, let's move that along. Nice. And let's make that go straight down there. Perfect. And let's. Nice. That's a nice strong acid, strong base titration curve.
That thing can't start at 0.
Why can't it start at 0?
Can't start the pH at 0.
What is the concentration of a solution if the pH is 0?
0.
0.
Wait, no.
Or is it?
How do you calculate concentration from pH?
10 to.
Oh, 1?
1. That's just a 1 molar solution then. Can you have a 2 molar solution?
Yeah.
Wait.
So you can have it less than 0. You can have negative pH. The scale is not an arbitrary scale where 0 is the lowest and 14 is the highest. Now that you're used to calculating, no. It's just a scale, and we put a negative number because that makes most of the numbers positives, and we like that. It's arbitrary. It makes logarithmic, so the changes don't happen too quickly. But you can have a negative 10 pH. The only thing limiting you is how much hydrochloric acid can actually dissolve into solutions. So for a negative 1 pH, you'd have to have a 10 molar.
So that's a lot of HCl.
That's a lot. Sulfuric acid, I believe, doesn't get higher than 18 molar. You cannot shove more sulfuric acid in water above 18 molar. So you're not going to get a minus 2 pH. Yes?
Like, so what sort of things could have like
Sulfuric acid at 18 molar. And hydrochloric acid can get up, I think, about 10, but I don't know how far. But they're not a lot. Like, if you said, oh, I have a 100 molar solution, like of what? What dissolves in water at that amount? You have so much stuff in there, the water wouldn't carry it. Most things would fall out either as a solid or bubble out as a gas. So it has to be able to dissolve in water, so that limits. Okay. Felix, can you put away your laptop?
Yeah. It's chemistry.
No, put it in your bag.
I was working on my lab.
Lies. Okay. What will be the pH? Right here in the middle. 7. So with a strong acid and a strong base. Oops. Oh dear. And I just want that one. This will be a pH of 7. And if you were doing this titration, and I was to drop down these values here, if we look at the change in, I'm going to use green for the ones it's not in the middle. So we have 8, 9, 10, 11, 6, 5, 4, 3, 2, 1, 0. Excellent. Yeah, perfect. This range here, for the volume of base added, is quite narrow. Question?
No, it's just.
Taylor? Question?
No, it's just something from our comp class that looks similar to this.
What is the thing from your?
No, it's fun.
Can you
Like
send
it's just something Smith says like all the time.
What does he say?
Always talks about like infinitesimally small like change in things.
Oh.
He just keeps talking about it. Drawing
He
it up
says
on the
it
board.
every
We've
class.
literally heard the same phrase like 50 times, and we know how it works, and he keeps re-explaining it.
I guess he's worried. Okay. Now, compared to this range, where if we went from here to here, that's absolutely gigantor. Here, we have a very narrow range in which it's changing color. Extremely narrow. Which means if we're trying to do a titration, this actually really improves our accuracy and precision, because over a very small range, we can stop using the calculation, and that means our error bars for our volume of base are relatively small, because that color change occurs relatively quickly. What else what's going on different ends? Up here you have excess base. Down here you have excess acid. Right there you have the transition point. Hopefully that's where the color change is. It is also the stoichiometric point.
At 7.
Yep. When all of the acid has reacted with all of the base, what should the pH be? 7. And then as soon as you go past that, now you're adding extra base. And that's why you get that color change as you keep going through.
And we can calculate this transition point, yeah.
Pardon?
We can calculate this transition point.
You can calculate, well, you know it's 7. If you have HCl and NaOH, is there any salt that will make that will change the
So we
pH?
can calculate exactly how much it should be
If you know both concentrations.
that we need for the.
The purpose of the titration is usually that you only know one of them. And so the color change uses the volume and the concentration, you get the moles of the other one. Using the volume of the other one, you get its concentration. Take out your data table. What would be a good indicator for this? Eric?
Like the titrations we did, you know how we got like different colors?
Yeah.
Does that mean we got like different pHs? Like really
Yeah, but you're moving in this range. So you might it's a difference of a mil. It's not a difference of like 10 mils. Whereas in here, if we were using this as our error range, we would have big errors. But because this slope happens so rapidly, and you go through the pH, you end up that type of reaction allows you to be very precise.
Bromethanol.
Yeah, blue methyl blue.
What, bromomethyl blue?
Yeah.
It's a bromo. Bromo methyl blue. What's its range?
6 to 7.6.
6 to 7.6. What color is it below 6?
Yellow.
Yellow
And it goes to blue.
to blue. So if we were to put that on our chart, we would have an area of 6 to 7.6. So that would take us about here, where we would get a color change. And we would have yellow on this end, and we would have blue on this end. And unlike your lab, this would just stay blue after that. It would be yellow before that. But what change in the middle would you have? It'd go, what's yellow plus blue? Color theory. people?
Green.
Green? Really?
Yep.
Yeah.
You can't make a primary color from other colors. Stupid.
Green is not a primary color.
Lies.
Well, okay.
No, only for like
See, I really
lights.
hope you're
Green is a
joking.
primary.
I can't
What
even
are the
tell at
primary
this
colors?
point.
Pardon?
I can't even
Is
tell if
for
you're joking.
this
This
red
I
and
failed color
yellow.
theory in grade 4.
You're colorblind.
I'm not colorblind. I just didn't. I came into the class and all the kids had their crayons out and they were trying to combine colors to make other colors. But the teacher didn't tell me what they were doing. I came in late. I just saw they were making circles and they had a different color inside the circle and they had a different color outside the circle because of course they'd make one and then they color inside. So I just made a center circle and then carefully colored around it with a completely different color. And then the teacher came along and said, I don't know how you got those colors.
And then you failed grade 4.
Yeah, we had a little test on primary colors and how to make colors, and I totally failed.
Okay, what do you think the primary colors are?
Magenta.
Cyan. Don't
What
have-
cyan is magenta, the same thing.
Wait,
Yellow.
what?
Magenta's pink.
It's like taupe and brown.
No, okay. Hold on. I actually.
Cyan is blue, bro.
This is like.
It's eggshell white. Like, come on, all
No,
this
this
is
is
cyan.
cyan.
No, they're like two very different colors.
Okay, stop. We're not gonna argue about colors.
This is cyan.
Distinguishably different.
Okay.
Yeah, that's blue.
Cyan.
It's like close to gray.
Magenta. Very different.
Magenta's pink.
Like you can't like interpret that like.
Play some Minecraft and look at magenta concrete.
What's even funnier is that cyan is actually a super important color in chemistry because if you get exposed to certain toxic chemicals, your lips turn cyan in color and then you die.
So in your head, was magenta cyan as well? Like there
No, I
was.
think most of us mix up the words.
What's a
Narrow range for equivalence point. Were you paying attention? How dare you? Okay, what indicator do we use in our lab? Phenolphthalein. Okay, now everybody look up how to spell phenolphthalein. That'll be a question next day if you're late.
No.
Phenolphthalein.
Wait, Nils, can you even spell it? I mean, I couldn't spell ceramic.
I don't know if that's right. Is that right?
That looks right.
Wait.
No.
Is that the I and it is? I think it's the I. No.
It's
No.
T-H.
Oh, it's the A instead of the I.
Is it PHTH?
Yeah, it is.
Yeah.
Okay, and then?
A.
L.
E.
I.
Oh, I got everything but the A?
Yeah.
So technically you have to go out.
Yeah, you have to leave the class.
Yeah.
Nobody else got it right either. Like literally nobody.
I did it.
No, you
Nobody else
didn't.
in the chemistry
Well, looking it up just now. Whoops.
You didn't look it up. I am going to print you out a color wheel to keep on the wall.
I took art with Mr. Luna.
Really?
He also tried to teach me color
It might be
theory.
the type of thing he might
Wait,
not
why
want
did
to
you
tell
why did
people.
you take art with this one?
I wanted to see what it was like to be a student and go to class, and also I took art with Mr. Luna. I could sit and listen to him talk all day.
That's true.
Yeah. Okay. What's the range for phenolphthalein?
I'm totally
8.2
Dylan?
is 10.
Oh, 8.9. What?
8.2 to 10.
That's what I said.
8 point. I said 8.9. Okay. What color is phenolphthalein at 8?
Colorless.
Colorless.
Colorless. So this side is going to be colorless, which I'm going to represent by light blue. And above 10, it is pink. So if we were to put this, because that's the one you actually used on here, then our range is from about here. 8.2 would put, that's our phenolphthalein range, which means before here, it's colorless. Here, you get the lightest of pinks. And then here, you get nonsense.
Eh?
How is that nonsense?
Oh, it just goes like pink, red, like
Yeah, like it,
dark.
once you're beyond 10, boom, it's that dark pink red. Below that, below this, it's clear, but in the middle, you get that light pink. Now, is there an error in between using these two indicators?
Yeah.
Roughly, if we were to do this one, our range, and I don't know if you can duplicate this on there, but I will try. Let's make it nice and thin. The range on here goes from, oh, garbage.
Yes.
What?
What? Nothing.
Okay, this range goes from there to there.
I can't see it. It's too thin.
I'm doing things. And let's make this color, let's purple. And I want it that one. And then this one goes from here to there. Is there an error? Yes. In this one, you're going to get slightly more accurate results. But are you going to get consistent results with this one? Yes. Are you going to get really close to the same right answer? Yes. And one of the things when I drew this curve, it's actually a little steeper than what I drew it. They overlap considerably. That's a fairly steep curve. And you can see even on this rough drawing, they're fairly close together. Even if you pick the wrong indicator for an acid or a base and it doesn't overlap 7, you're going to get good enough results most of the time. So long, steep curve, strong acid, strong base, very narrow range in which it changes color that allows you to be able to figure out where is the transition point. It doesn't overlap perfectly with the transition point, but you're going to be close in terms of the volume every single time. That's enough.
Wait, Mr. Newfield.
Yes.
So if you have like 2 indicators,
2 indicators.
yeah, then is it going to like first turn yellow, then turn green, then
Oh, yeah.
turn blue?
Because, that's in our other notes.
And then is it going to turn colorless?
What at the end of our notes in the last unit, I gave you a display of the universal indicator. How do they make that?
They combine every
They
single.
just combine all the indicators. Certain ones, so they get a spectrum like that, and that's how you can determine
Mr.
pH.
Newfound,
Yes?
how do you determine which indicator you need to use?
You want to use one that overlaps with the transition point.
And is the transition point always going to be the middle of the graph?
No.
How do you
Because
know it's
the very next thing I'm going to do is what if we had not a strong acid, but a weak acid with a strong base? If you have a weak acid with a strong base, when it's done reacting, what are your products?
It's going to be excess acid and it's
No,
gonna be,
no, when it's done perfectly reacting at the stoichiometric point, when it's all done, are your now this one the products are neutral. What will the products be from a weak acid? Yeah? No?
No, basic.
Basic. Because a weak acid, its product is a weak base. So the transition point's actually going to shift up here. Not like in terms of the curve, and you're going to have, it's not going to be as long, and you'll have to pick indicators that go either one depending on what you have. So this is the easiest case. It's always going to be 7, strong acid, strong base. But we're going to do other cases in which it's weak acid, strong base, and then strong acid, weak base. You don't do weak acid, weak base, because then you have Kas and equilibrium, and everything just goes to hell in a handbasket.
So we don't do that?
You don't do that for a titration. You don't get accurate titration. The titration curve isn't steep. It's actually kind of really slopey when you have that because you have an equilibrium moving back and forth. But a strong acid or a strong base forces the other equilibrium to go, so you can still do it. This is why we did a primary standard. We titrated it. That primary standard was a weak acid. We then titrated our strong base, NaOH, and then use that as a strong base against a bunch of weak acids. And we'll do that one next. Good? Okay, now's the time for the formative quiz. And if you could take your Hebden, and put it on this table. This table. This table. please get out your data tables, a pencil.